Hello, my name is Dalim Rulua Victor. I'm here to make my presentation on this model with the problem statement as follows. So the Nigerian National Grid has been facing series of system collapse for years, and it begs the question, why exactly is the grid collapsing? And one of the reasons why a grid would collapse is if this grid is not transiently stable, in the sense that when a particular fault happens, the system either takes a longer time before the generators synchronize together, or if the system is not transiently stable, the generators of the system, after a particular fault has happened, will not synchronize together again, which eventually results to collapse. Now, this particular model explains that, in the sense that it assesses a particular section of the grid where the particular section named Binibus, alright, is responsible, or it has the ability, alright, to collapse the entire national grid if a particular fault should happen to it, especially a fault as severe as three-phase fault. Now, what we try to do, alright, is to assess that particular grid system, that particular section of the grid, where we modeled it using the Delta and Sapele gas station, the AFAM 225 and AFAM 60 gas station. This particular section, this particular model rather, alright, it's part of the components of the particular Binibus we're trying to work with. Now, this particular system, comprises of two generators, in the sense that we use the swing equation, right, to combine these two generators together, which is what also happened here. Now, we combined it by adding the normalized inertial constant, alright, for these two generators, right, where we added the H1 and H2, and then it was able to comprise of that particular swing equation we're trying to deal with. Now, this particular with the as this particular turbine and regulators, it comprises of the excitation, alright, and it comprises of the steam turbine gas station, in the sense that this particular gas station, alright, is a thermal gas station, alright, it's a generating station rather, it's a thermal gas station which requires a steam turbine, alright, and this particular turbine and regulators, alright, works with a particular power system stabilizer named the multi-band system stabilizer, okay, which was modeled from the idea of Kondo, right? And this particular voltage stabilizer was connected. This particular one used with this one here, it was connected to this particular section, and this PSS one, which comprises of it will display shortly, and then it's connected to the excitation, which consists of the voltage stabilizer, the VQ, the VD, and reference voltage. And then section of the machine itself, alright, it has a reference power of 455 megawatts and a base power of 1902 megawatts. 1902 megawatts is like the capacity, but it uses 455 megawatts, alright. And when we divide this 45 megawatts by 1902 megawatts, that's how we got this 0.23922, right, which represent the reference power, and then it's what this particular section generates at minimum, alright. And this same thing applies to this one too, why the other one also has 1.0 but then it ranges from 1 to 1.05. Now, for this section, alright, the Bini Onitsha, we are trying to model the transmission line, alright, which consists of the bus, which it uses a voltage current measurement block, alright, which acts as the Bini bus, same thing as the Onitsha bus, same thing as the Alaoji bus, where we are able to extract the voltage and the current when we run the simulation. This is the circuit get a value, alright. And then this fourth block, we use it to model both the three-phase to ground faults, where if we choose just this and this, it runs the single phase to ground. It can also run the double phase to ground by this, and then three phase to ground. And if we want to run the sudden drop in a generator, we can just open this breaker, and then it drops that particular generator. And then same thing applies to this. This is transmission line. This is different from this, in the sense that this is for short transmission line, and then this is for long transmission line. The one which has 136 megawatts as the active power, so it draws 136 megawatts from the grid, and a 50 hertz frequency, and that also applies to this load 3 and also applies to load 2. Same idea, but different data in them. Now when we want to run the 3-phase to ground fault, all right, we choose all of this and then we run it over 20 seconds, and then we have the following: 3-phase to ground.
Oh wow.